Hello, class. Welcome back. We are looking at lesson 7-9, geometric sequences as exponential functions. Now, our last lesson was 7-5. We are skipping over 7-6, 7-7, and 7-8 because they are things that do not lend itself well to online learning, and they are transformations of exponential functions. We will go over those if we have class, and if not, we will catch those up later. Okay, so geometric sequences as exponential functions. We need to go back to Unit 3. I need you to think back to arithmetic sequences. I don't know if you remember this, but arithmetic sequence has a common difference. So those are patterns like 3, 6, 9, 12, or 10, 7, 4, etc., where they're going up or going down by the same number. It has a common difference. We're adding or subtracting by the same number. And if you recall back, there's an equation, a sub n, a to the n, which means whatever term this is, a to whatever term is equal to a sub 1 plus n minus 1 times d. A sub 1 is the first term, and d is the common difference. So what you need to be able to write an equation, remember we did this months ago, is you need the first term and the common difference, and then you put that in there, and that will give you the equation for that arithmetic sequence. So let's look at this. So you have 3, -10, -23, -36. Now this is we are subtracting 13 each time. That is the pattern. A1 is the first term. The first term was 3 in our sequence. The difference, we are going back by 13, so subtract 13 each time. So then we put that into our equation. A to whatever term, to find any term, is equal to a sub 1 was 3 plus n minus 1 times d was -13, the common difference. Then we will distribute the -13. So we've got 3, -13 times n is -13n or -13n. -1 times -13 is +13. Then you combine like terms, and you've got a sub n equals -13n plus 16. So we did that in Unit 3. That was arithmetic sequences. Well, geometric sequences, we're going to look at them side by side. A geometric sequence has a common ratio. So instead of adding or subtracting by the same number, you are multiplying or dividing by the same number. The equation looks different. To find any term, a sub 1, again, is the first term. R stands for the common ratio. The common ratio is what are you multiplying by, okay? So what's your multiplier? Now, up here I said divide by the same number. If you're dividing by something, if your numbers are getting smaller, you're multiplying by a fraction. So let's say you've got, it's got 20, then 10, then 5. We are dividing by 2 each time. Well, the common ratio is 1/2 because 20 times 1/2 is 10. 10 times 1/2 is 5. 5 times 1/2 is 2.5. So the ratio needs to be what is your multiplier, okay? So let's look at an example of, here is a geometric sequence, -6, 12, -24, 48. There's two things that I'm noticing. They are doubling each time. So that is a multiplying by 2, but also the signs are changing each time. So we are multiplying by -2. So -6 times -2 is 12. 12 times -2 is -24. -24 times -2 is +48. So the common ratio is -2. A sub 1, our first term, is -6. The ratio is -2. So then we're going to put it in our equation. A sub n equals -6 is a sub 1. The common ratio is -2 to the n minus 1 power. Now, this is as simple as it gets. We cannot multiply these two because this is not 2, this is 2 to some power. And if this had n to the negative first power, then we can multiply them. But because this has an exponent that is different from this exponent is 1, you cannot just multiply them together. So this is in simplest form. All right, you may want to rewatch this a couple times to kind of catch all of that. I know we're going fast. So let's look at some of our problems. This is divided into 3 parts. The first one says determine whether the sequence is arithmetic, geometric, or neither. Now, arithmetic, again, you're adding or subtracting by the same number each time. So it's going up by the same number or down by the same number. Geometric, you're multiplying or dividing by the same number. Neither, you don't know what's going on. So let's take a look at this. Let's look at number 2. We're going to do the even ones on this one together. -96, -48, -24, -12. All right, all of our signs are the same, so we're good there. I noticed that these are being cut in half. They're being cut in half. So our multiplier is times 1/2. So 96 times 1/2, -96 times 1/2 is -48. -48 times 1/2 is -24. -24 times 1/2 is -12. This has a common ratio, so this is geometric. Explain, because the common ratio is 1/2. Okay, let's look at 4. 4 goes from 3 to 9 to 81 to 6,561. So let's see, we're not adding, we're getting bigger. So we're not adding because this by the same thing, because this is 3, then 6, this is plus 6, this is plus 72. So we're not adding by the same thing. Are we multiplying by the same thing? 3 becomes 9. 3 times 3 is 9. 9 times 3 is not 81. So this is neither. It doesn't have a common difference. It doesn't have a common ratio. Okay, let's take a look at number 6. 3/8, -1/8, -5/8, -9/8. So we're all in the land of eights. We are subtracting. So let's see. To get from here 3 to -1/8, you would subtract 4/8, right? And -1/8 to -5/8, again, we're going back 4/8. And then -5/8 to -9/8, back 4/8. All right, so we are not multiplying or dividing, but we are subtracting 4/8 each time. So it is arithmetic. Arithmetic. Because the common difference is, please do not put 4/8. It is 1/2, or it's -1/2 actually, because it's going back. All right, so on these, you need to see, is it arithmetic, is it geometric, or is it neither? All right, let's look at the second section, which is find the next 3 terms in each geometric sequence. Well, they tell us it's a geometric sequence, so it is multiplying or dividing by the same thing. All right, we are going to look at 9 and 10. All right, so 9, -4, 24, -144. Okay, we are going up, so we're multiplying, but look at what's happening to our signs. Our sign goes negative, positive, negative, positive. So that means we're multiplying by a negative number because the sign's switching each time. So this is going to be times -4 times 6 is 24. So -4 times -6, positive 24. Positive 24 times -6, -144. All right, so we need to subtract by -6. So I just would use your calculator. -144. Ooh, there's a bug. I'll use on my calculator. What is that? Okay, -44 times -6 equals 864. And then we got 864 times -6 is -5,184. -5,184 times -6 is positive 31,000. 31,104. Make this a. All right, so there's our next three terms. All right, let's look at 10. What is happening with 10? 4/8, 4/5, 2/5, 1/5. I have 4/5 and I have 2/5 and I have 1/5. We are cutting it in half each time. So this is multiplying times 1/2 times 1/2. Okay, stuck. All right, so I think we can do this in our heads. 1/5 times 1/2, 1/10. 1/10 times 1/2, 1/20. 1/20 times 1/2, 1/40. All right, that is what you do there. So for the rest of them, find what you're multiplying by and keep it going for 3 more terms. All right, number 13 asks you, from 13 on, it asks you to write an equation for the nth term of the geometric sequence. And again, we are going to use that formula. I'm going to write it up here just to help me remember. Is a to the n equals a to the first power times the ratio to the n minus 1 power. All right, so let's see. And then so 13 says, write an equation for the nth term of the geometric sequence. Find the seventh, oh, I skipped one. 13, write an equation for the nth term of the geometric sequence, 3, -24, 192. Find the 9th term of this sequence. Okay, I already know a to the a sub 1 is 3. It's the first term in our sequence. We got to figure out what's going on here. Well, 3 to -24 is times -8. 24 times -8 is 192, positive 192. So R is -8. Now that I have this, I need to put it into this equation. So A sub n is equal to A sub 1, the first term is 3, times the ratio is -8 to the n minus 1 power. All right. Now this is my term, or my equation, it is in simplest form. We are looking for the 9th term. So that means A sub 9 means the 9th term is 3 times -8 times 9 minus 1, which is 3 times -8 to the 8th power. Definitely need your calculator for this. So I am going to do 3 times negative 8 raised to the 8th power. And that equals a huge number. Negative 50,331,648. So a to the 9th is negative 50,331,648. Whew, that is 13. All right, 14. 14 was a little bit of a struggle for me when I was looking at this earlier because I was going 9 to 3/8 to 1/4. I can see a pattern, but I couldn't really think about what are we multiplying 9/16 by to get 3/8. And so I had to think about for a while, how can I figure out what my multiplier is? And looking up here, 3 times negative 8 is negative 24. I could divide negative 24 by 3, and that would give me my common ratio. So I'm going to take 3/8 divided by 9/16. So we got a nice little calculator for that. 3/8 divided by 9/16. 2/3. All right, so looking at this, a sub 1 is the first term is 9/16. The common ratio is 2/3. So I need to put that in my formula. A sub n is equal to the first term is 9/16 times the ratio is 2/3 to the n minus 1 power. And then it asks us to find the 7th term. So we're looking for a sub 7. That's the 7th term is 9/16 times 2/3. N is 7 minus 1 is 6. So I'm going to do 9 in my calculator, 9/16 times 2/3 to the 6th power. 9/16 times 2/3 raised to the 6th power equals 4/81. So the 7th is 4/81. There's your answer. All right, 15, I want you to try on your own. Let's look at 16. Write an equation for the nth term of the geometric sequence, negative 8, negative 2, negative 1/2. Find the 8th term. Okay, a sub 1, the first term is negative 8. The common ratio, what is happening to go from negative 8 to 2 to 1/2? Well, we are dividing by 4. Negative 8 divided by 4 is negative 2. Negative 2 divided by 4 is negative 1/2. However, the common ratio is your multiplier, not your divisor. If I am dividing by 4, is the same thing as multiplying by 1/4. So the ratio is going to be 1/4. So 1/4 of negative 8 is negative 2. 1/4 of negative 2 is negative 1/2. All right, now that I have this, I can put it in my formula. A to the sub n is equal to the first term, negative 8, times the ratio, common ratio, 1/4, to the n minus 1 power. That is the formula. So that's the part 1. The next part, find the 8th term. So I'm looking for a sub 8. That's the 8th term, which is negative 8 times 1/4. You need 8 minus 1, which is 7. So in my calculator, I'm going to do 8 times 1/4 raised to the 7th power. Enter. All right, that's a big giant. Oh, I forgot to make it negative. It's got to be negative. This is negative because the 8 should be negative. All right, so it is negative 0.0004888281, etc. All right. I want you guys to try 15, 17, and 18. If you have questions, don't feel free to contact me. And we are almost finished with Unit 7. I think we have one more after this. Have a great one. See you later.